Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this DevOps Roundtable. My name is Cody, and welcome back to Techstrong Learning. Before we dive into our conversation today, I do have just a couple of notes for everyone. First off, we are recording our session today. So if you happen to miss anything, if you'd like to watch again later, or if you'd like to share this conversation with your team, you will be receiving a link to the on-demand recording as soon as we wrap up this live recording today, and we'll be sending that to you via email. Now, if you would like to be involved with our conversation, there are a couple of ways to do so. The first option is to use the chat tab on the right side of your screen. So when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. Now, if you have specific questions, we do want you to submit those to the Q&A tab on the right side of the chat section. This is a largely discussion and dialogue-based program, so be sure to send in your questions and we're going to do our best to bring them into the fold. Now, additionally, if you jump to that handout section, you'll see there are quite a few resources, so take your time downloading all of them, checking them out, and let us know if any of them were particularly useful for you. And we will be selecting 2 of our most engaged attendees today to win a $50 Amazon gift card. So ways to become eligible are to send in your chats, your questions, and of course, filling out our post-webinar survey. A link will be in the chat toward the end of our program, and you'll also find it in the handout section. So on to the meat of our program today. We're going to be discussing solving cloud-native complexity with AIOps for observability. I'm joined today by Josh Hardman, Solutions Engineer at Conviva. We're also joined by Yaron Front, Product Director at BMC Software. We also have Nora Johnson, Solutions Engineer at Conviva. And our final panelist is Stella Udovicic, Director of Solutions Marketing at BMC. Now, keeping this conversation on the tracks as usual is our very own Mike Bizard, Chief Content Officer here at Techstrong Group. So Josh, Yaron, Nora, and Stella, thank you all so much for joining us here on Techstrong Learning. Mike, would you like to dive us right into our conversation?
Absolutely. There's a lot of ground to cover. Well, let's just get started by trying to level set this a little bit, though, because there's a lot of folks who I think they're all familiar with monitoring, but they may not all know exactly what observability is. And sometimes observability is in the eye of the beholder. So Stella, let's start with you and kind of bring us up to speed as where are we on this proverbial journey into observability?
Thank you very much, Mike. Yes, there's been lots of discussion in the industry. What exactly is observability? And I feel we're with that discussion similarly when we discussed what is DevOps. The way we talk about observability and current state of observability is that we're seeing that observability is going mainstream, and then observability is different than monitoring because you have many more metrics, traces, logs, lots of data, velocity and volume of data come into observability can be really, really high. Also, on top of the observability data sources, what you also have is applied machine learning to make sense out of the data. When you look at more traditional monitoring, when you have more discrete, you're monitoring just a few points, you're monitoring network, or you're monitoring your infrastructure. In observability, you have many points that you're monitoring, therefore the volume of data that's coming in is really huge. Also, when we talk about observability at BMC here, we also expand the definition a bit, going beyond just those metrics, traces, logs, and AI. We also ingest data from knowledge articles, incidents, and all that to bring a much more exact picture about your environments and your applications.
All right. Josh, do you want to add to that and add a little perspective on the other topic that we're touching on here, which is cloud native? Seems to me IT environments are getting more complex by the minute.
Yeah, it's a great point. I don't think it would be a surprise to anyone to say that as applications and systems have moved to the cloud, the types of services that can be delivered and the way that we use and deliver them has grown, right? There are many more options than used to be the old install it on a server and run it. Now we are, multifaceted, running microservice environments. With observability essentially being, trying to understand or interpret the status of that system based on its outputs. Melt data, metrics, events, logs, and traces, as Stella has said, absolutely core to understanding how that works. one thing that, as we talk about, solving the problems that the complexity brings, that I like to focus on, and maybe we'll get through in today's conversation, is saying it's one thing to understand the status and how your system is running, but it's another thing to understand what does that mean to your user or customer, and how is that being delivered to them? Because those can be two different things. One system could be running as it's intended, but the customer not getting what they're expecting. And so I think that's the big thing to put our arms around and say, how can we do that both with AI and with just native natural systems and learning and understandings ourselves?
All right, you're on. We are playing buzzword bingo early on here. We have a trifecta. So we have AIOps as the third leg of this thing. Yeah. Explain to us a little bit where AIOps fits in with what Josh and Stella just described.
Yeah, so if you look at this and if you have a perspective of time, you see that if once it was, we need data, we need to know what's going on, we need to monitor these systems, we need to get all that information in. And that's kind of transitioned for a lot of our users into, we have too much data. How do I all of it? How do I get everything in context? How do I preserve knowledge? How do I know that, this happened 3 months ago, and maybe I should do the same thing today because I've already seen it. But, do I really need all of these domain experts to come in and solve the problem? And that's where AIOps and machine learning, like Stella was mentioning before, that's where that all comes in. So with AIOps, you're able to make sure that the services that IT provides have the right service levels and reliability. You're able to, then if you run into a problem, you're able to accelerate how quickly you can actually solve the problem. You're able to do it more naturally. You don't need to be a subject matter expert for every different system and every different technology, because we've got a blow up of different technologies nowadays. Nobody can be an expert at everything. So do I really need a war room? Do I really need to get 15 people in a room because one of your SaaS customers has an outage? No. And kind of the third leg of that is, why do I even need to run into problems? Can I be predictive about it? Can I know that, yes, there's something happening with a specific service that I'm giving that might cause a problem, an hour from now, maybe tomorrow, maybe even a week from now? Am I able to solve these problems even before they impact the actual users? And there are different ways of doing it. You want to reduce noise. You want to be able to have the system tell you where the problem is. So things like root cause isolation, automations, best action recommendations. And people just can't do it nowadays. It needs, you need AI and you need ML to help you.
Nora, you talk to a lot of customers. All this sounds terrific. Why doesn't it just work overnight? What are the challenges that people are running into as they kind of come down this path? And what do you need to help them get through?
Yeah, great question. So as some of the other panelists have mentioned, for a long time, the attitude among DevOps and engineering organizations was that if you just collect all of the data that your systems produce, you'll be able to figure it out. It'll tell you when there's a problem. It'll tell you how to fix it. And we've been very much let down by that. I think it's a pretty common occurrence, I would say, at least for me daily, that I log into an app or a website and it doesn't do what it's supposed to do. And maybe it's not it's just a small inconvenience, but sometimes it's the difference of being able to actually use the website or not. And so the hope is that what we've ended up doing is we've sort of burdened ourselves with all of this data. And as Yaron was mentioning, the hope is that using artificial intelligence, we can actually alleviate some of that burden by being able to look at all of the data that we've collected. Some would say maybe too much, but we actually look at all of the data that we've collected and do two things with it. One is be proactive, and two is be reactive, but faster, right? So being able to proactively say, here's what we anticipate is going to happen in our system, and then reactive, looking back at some of the things that have happened and really understanding why they happened. But doing that in a way that alleviates or lowers the barrier to entry, because as my panelists had mentioned, we want to be able to dive into the system, but we don't want to have to be maybe a Kubernetes expert and a JavaScript expert and a SQL expert, right? We want to be able to ask human questions. We want to be able to leverage natural language by asking questions like, why am I seeing this happen? And then getting an answer back. And by using artificial intelligence and machine learning models, the hope is that it can do a lot of that undifferentiated heavy lifting by looking at all of the data, comparing it to what it's seen, and giving us some sort of user-based, experience-based insight and recommendation, rather than relying on us as individuals to know everything about every single system that makes up our architecture, and having the experience of having seen that before and knowing what the best course of action is to take.
All right. Stella, to Nora's point, all too often it requires specialists and people who have titles like engineers, like the folks on this panel. Are we on the cusp of maybe getting to some level of democratization of this stuff so that I don't have to be a rocket scientist and I can be a mere mortal IT person and manage all this stuff?
That's exactly where it is going, especially as Nora mentioned, because now you're communicating with your system using natural language. And think about this: if you're onboarding new team, new engineers, you don't need to learn another query language. Your ramp-up time are really, really short, so that you can immediately get to this productivity level as the rest of your team. So there's more efficiency in IT teams, engineering teams, SREs. Immediately they can be active and contributing to the bottom line instead of long ramp-up time. So that's one. And also today there's big restriction on budgets, especially in tech companies. So you are really asked to do much more with the same team. And that's exactly what we're going to see with the application of AI and observability, is that your engineering team will be freed from traditional toil, chasing incident after incident, going after fires, and that will be already surfaced for them by AI. Therefore, they can be free to focus on contributing to the business and build new services. So that's where I think everything is going.
Yaron, add to that, how heavy a lift is this going to be? And I'm asking the question because, I mean, you know more about AI than I'll probably ever know in my lifetime. But a couple of things come to mind. One is we have predictive models. We have these new generative AI capabilities, and some people have this causal capability. Do I have to know all this stuff on my side as an IT person, or are you guys going to take care of all this for me?
So, it seems like it was a long time ago, but things like ChatGPT and large language models, they came around, like a couple of years ago, maybe less. Maybe that was a year ago when they debuted on the stage. You don't need to understand large language models to use ChatGPT. You don't need to understand large language models, machine learning, artificial intelligence in order to be able to solve problems quicker, predict when problems are going to happen, because that's what these tools are there for. They're there to make it simpler. They're there to make it more intuitive. They're there to come in and tell you, here is where the problem is. The problem is linked to a specific service that you are giving. Here is what I recommend that you do in order to solve the problem. Here's what you should do in order for that problem to not happen again. And all of this, huge technology in the background, it's like a black box. At the end of the day, it's truly meant to be used by people who just want to be able to solve the problem, solve it quickly, make sure it doesn't happen again. Okay? So basically, instead of, if in the old days you had to sift through logs and look at cryptic event messages saying that you had error 53 in system HI19, that may be a server somewhere. Nowadays, because the complexity is of the environments and the different technologies is so high, the role of AI, and specifically Gen AI and models that come into AIOps, is to make it simpler, more direct. And I've seen customers who've taken their MTTR, who've taken their time to repair a problem from a couple of hours to minutes on average, because this system doesn't require you to get all the experts in, like everybody else was saying before. It just tells the person looking at the screen, here's a problem, here's what you should do in plain language.
All right, we have our first question from the audience, and naturally, if you mention the word AI, some skepticism follows suit. So the first question is, so how do we test the accuracy of the methodologies used for the various models? Because that seems like that part requires a significant amount of rocket science, shall we say.
So that's a great question, and it's a very common question, to be very honest with you. Every time, I go in, and maybe you can tell I'm very passionate about this. So every time I go in and I talk about the models, and I talk about large language models and GPT and how it can help and how it can fix problems before they happen, I oftentimes get these kind of questions and kind of skepticism that says, how do you know this is not hallucinating? Because people have heard this term, hallucinations, or how do I know that it's going to get it right every time? Well, the answer is you don't. You don't know that it's going to get it right every time. But since this is a learning machine, and since we know that what computers know how to do a lot better than people do is they know how to analyze and recognize patterns and trends. Okay? So the first thing is the system is just as good as the data that's fed into it. So the more data you bring in, the better your results are going to be. So if you can bring in data from your ticketing system, so from your IT service management, and from from all of your different monitoring systems, if you can bring it all in, the machine knows and the machine can learn. And the way you test that is you can always simulate, and you can try and see what the results would be if something happens. Now, if you're talking about predictive analysis, which is, again, a very strong part of AIOps, so you can run scenarios based on information that you had in the past. So if I'm, just as an example, if I'm a retailer, right? I know what shopping season looks like. I know how it affects, what impact it had last year. So if I want to simulate that, AIOps can do that for you. It can simulate what's going to happen next, and you can test it out on last year's data versus this year's data. So there are tools that can give you more comfort in the results that you get. And although you can automate a lot of it, I mean, you can set rules and you can put in things. If you have a true AIOps kind of a platform for AIOps that has different components to it, you can have automation as part of it. So tell AIOps, if you see X, do Y. But not a lot of people start off with that. Oftentimes they start with, well, if X happens, tell me about it, and then I'll click a button and do Y and do the automation. So there are different levels of maturity and getting to it. But what we have seen is that if you have the data flowing in, if you have the monitoring, if you have the different connections to the different systems and technologies, and things like Jira and ITSM I mentioned, and knowledge articles and all that, even day one, you are going to see good results.
I'd like to
Josh,
add, Mike.
So go ahead.
I had a point to add, just to add to this topic is also it's important to understand how you train your data in terms of whether that's the data from your IT environments. It's not like you're looking at ChatGPT and any data out there. When we are working with our customers, we're training the data on your system. We are training the models with your data. On our data, entire history, and if there is, like, we are seeing some, that's a common question, whether it hallucinates. But what we are also doing, we are adding reinforcement learning, which means that we are also adding human in the loop to say, yes, that's right or not. So we're getting much better accuracy as we progress and work with our customers on training these models.
All right. Josh, we have a question. Go. Well, let me ask the question, and then you can throw in your 2 cents because it's all related. But We have a question from the audience who's, wants to know, what is the level of IT background and experience that will be required to make all this work? Because on the one hand, we're talking about democratization, but on the other hand, it seems like you really have to know something about what the data is that was used to train the model. So what's your take? Where are we?
Yep, absolutely. We like to use a lot of these buzzwords internally here as well. Democratization of data is one that we say frequently. Another one that we use a lot internally, we call explainable AI. And I think this touches a little bit with the AI models that we attempt to build and use on top of this data. Not only will we say, hey, this thing is slow and here's why, we surface the indicators that were used to make that decision. So this experience for your users that you're providing has gotten slow or has started to fail or has some problem. And we know that because, and then we spit up on the screen all of the different outputs. What was it that caused that? So it gives you trust in the outcome. Well, okay, I could, logically, I could believe that those things, if they happen, is going to lead to result X. But also it does take away some of the guesswork and some of that, expertise that you might need to have, because we use, as was said earlier, human language to explain it rather than, technical terms. So you might have internally, many systems. A lot of people have similar systems. Like pretty much everybody has, several systems for subscribing people, for logging people in, for doing all of these activities. Internally, they're all unique and custom and have their own names. But if you have a model or a system that allows you to sort of map these into experiences that matter, give them names that you all understand and agree on, and the AI says, your login experience is having a problem, and these are the outputs that are contributing to it, and it comes from system X, whatever that example might be. You don't necessarily have to be a super experienced person, because you know what logging in means. You understand what that experience is like. You need to provide credentials and be authenticated. And then we tell you, go look here, and then provide, and all of the logs and traces and everything are underpinning that you can then give to the actual person who's going to do the fixing. Now, the hands-on coding and fixing of the problem might require specialized knowledge of that system, but just identifying and understanding the impact of an issue, where it's at, and what to give that engineer to fix it as fast as possible gets you most of the way down the road of getting to that fix.
All right. As we kind of think about that for a minute, Nora, what's going to be the impact on the relationship between IT and the rest of the business as we kind of go down this path? Because we've been talking about this divide for decades, and it doesn't seem like we make a whole lot of progress. But are we on the cusp of something here where an IT event equals a business event, and we can all talk about the same thing at the same time?
Yeah, absolutely. So as Josh mentioned, there's been a movement to think less about just pure system performance, things like, is my login API working, and more about experience-centric perspective, right? So is my login time quick? Is it pleasant and easy and painless the way that it should be? And as we see AIOps and AI get more integrated into DevOps practices, it's actually we're going to see a shift from being less tactical, less writing scripts, troubleshooting, pouring through Stack Overflow forums, as so many of us have spent kind of sleepless nights doing, to being more strategic. So thinking about system design, making architectural decisions, interacting with sort of low code and no code tools, things like chatbots, where you can say, hey, I'm seeing this performance, or I'm seeing this error. Can you tell me why that might be happening? And getting to that answer a lot more quickly. But what's going to come with that is the ability to collaborate with other domains, interacting with maybe cybersecurity teams, data science teams, interacting with business analytics teams, so that you're not so siloed, sort of in the way that we used to see, and still to some extent still do see. There's development teams and there's operations teams, and they kind of threw it over the fence and hoped for the best. And we realized this is really not a good way to work together. We're seeing a sort of similar thing happen with the DevOps engineering organizations, and then those product teams, the analytics teams. So it's not just, hey, I'm going to make sure that all of my APIs are working, that my database is performant, and then I'm going to hope that that actually results in some improved experience for the user. And I'll leave it to the product team over there to, update the color schemes or the click path that they anticipate users will use. We're seeing a movement of those teams actually working together and saying, okay, maybe all of my APIs are responding fine, but for some reason, people are leaving. People are abandoning my website. Why is that happening? And to get to the answer to that question, we have to marry the application performance or the system performance questions that we're used to asking with the questions that product teams and analytic teams are used to asking, and ask new questions, like Josh was mentioning. How is system performance impacting the actual sign-up experience? If I'm trying to discover new content or be recommended new products, and that really requires both teams, both organizations to work together to come up with new questions that are a little bit different from the way that we're historically used to asking as DevOps organizations or as product organizations.
Yeah. Stella, anybody who's been down the observability path knows that you encounter a lot of data. And some of those organizations are already choking on that data. So how do I kind of approach this where I'm collecting all kinds of telemetry data from all kinds of points and systems? Where am I supposed to store that? How do I analyze that in a way that doesn't wind up costing me more in data storage costs than I got for any benefit?
Yes, it all depends which vendor do you ask this question, but not all data is created equal. There are some data that's more useful than the others. For instance, when we are looking into incident data, IT tickets data from a service management tool like BMC or Jira, etc. You take action on the data connected to the development system, and then you don't need that data anymore. Also depending on what kind of data, like if you're having things such as tracing, you have like short-term storage needs when you are debugging the application. If you're looking at log data, for instance, then you may want to decide whether you are storing data short-term for application troubleshooting or long-term for more forensic analysis. But nonetheless, what's important is if you're applying AI on top of the data, we need to make sure that we have good data, comprehensive data, so that we can also build models, graphs, topology data, as we want specific reliable insight. The things such as discovery is very, very important, because discovery of specific relationships in your environment is now fed into all these models that are generative AI, causal AI, predictive AI. So good data in, good output, you get good results out, and you store data depending on your use case.
All right, Josh, you want to add to that? Because in my experience, a lot of organizations aren't especially good at data management, and things are kind of a bit of a mess. So how do I get started?
Absolutely. And I've spent time at, I won't name names, but these large SaaS-based observability tools, it is in their best interest for you to send them more and more data, right? A lot of them, that's how they bill and how they bring their business value to light. And so gathering as much data as possible is something that they're making easy, and quick and painless to use. I imagine a world, I don't know that I have an answer to this problem yet, but I imagine a world in the future where we only collect data when there is a problem at hand, right? I oftentimes will tell people we collect all of this data, we collect all the metrics, the events, the logs, and we have 99.8% uptime, right? To me, that's telling me I've got 99.8% of my data that's not contributing to solving a problem. It's just being collected. So imagine if we could only gather that data when there's something going wrong. If that's the case, the definition of problem becomes very important. How do I know when I have a problem so that we can gather it? And, as Nora was saying, I personally believe that as we shift this to a business focused model, what are our goals of our business? Are we subscribing? Are we selling? Are we, whatever the thing is that you're providing? When something is interrupted there and we have a drop in users, a drop in purchases, a drop in any experience, then we should capture the relevant data in order for us to solve that problem quickly. And that's where I think the future of all of this could go to the data management problem. Selective capture of data based upon the business rules that you have for your goals that you have at hand.
Yaron, I think Josh just made a challenge. Are you going to accept that, or where are we going?
Yeah. So look, we all know that AI, and specifically machine learning, is as good as the data that it's fed. And essentially, the analogy that I like to use is it's just like a high performance race car. And the engine is AI, but the fuel is data. Okay? And your car is going to run smoother, better, faster, more efficiently, the more high-grade fuel you have. So yes, I agree with Josh. We need high-quality data, but we also need more data because more data means that we can predict better, we can analyze better, we can find patterns better, we can suggest fixes better and quicker. I'll just tell you a story. I mean, where this is coming from. So like Josh said, I was talking to an ITOM, an IT operations management manager in one of the large banks in EMEA, and she told me that before they started using AIOps, if one of their critical online banking systems was down, she would get on an average 3,000 events. So she would just open her console and there would be 3,000 events there and probably 120 to 150 different tickets coming from different IT service management tools, ITSM tools coming in, and that would be her starting point. Now think about it. You got 3,000 events, and she told me the first thing which she would try to recognize from 3,000 events would be which service is down or which service is not working. Is it my online banking? Is it my teller system? Is it my loan system? So the fact that with AIOps, you can now, again, if you have all these sorts of information, if you have a platform that supports this, you get a lot of data, but you get that data within context. So if I know that a specific server or a specific application or process or network device is not working, I know that that one is critical to a specific, and it's linked to a specific business service, that narrows everything down and makes it a lot simpler. So I think that if the problem that we're talking about is I have too much data, the problem is not that I have too much data, is that I have more data than I know what to do with. And if you want to know what to do with the data, that's where AIOps and machine learning and large language models come in, because they can take all that huge information that no human can ever understand and narrow it down to a sentence. So I did a demo recently where you see it. You see 3,000 events, 5 incidents, everything coming in. But at the end of the day, the operator gets one line. It says, this service is experiencing slowness. It's because this database is running out of memory. You should probably add memory. And it's, it could be a result of the change or the update that you did over the weekend. One sentence, human readable.
Yeah.
Nora, go ahead, Josh.
Sorry, I just wanted to add to that. So your own, when you mentioned you get these 3,000 events and we say what service is impacted, you mentioned, is it my online banking? And to be honest, the way we think about these things internally, the engineering team thinks of a service as some small core piece of functionality that provides something. Online banking is likely stitched together of many internal services, but to the consumer, the outside world, it's a service, online banking. And so being able to differentiate, okay, this internal small service is down, but what is that impacting on the external service front can be very hard to figure out as well. These systems become spider webs. And so having AI tools that can tell you this service is down, and that means this thing is not working that your customers are paying you for. That's hard sometimes to correlate, and that's where AI needs to step in.
And one of the, absolutely, Josh, and again, we see this every day, and today I saw it at least twice. One of the big challenges, just like you said, is to define the business services. So how do you link those in, right? Because a database might be linked to several small services that impact the big business services. So, one of the real advancements that we've seen that is a true part of AIOps are things like dynamic service models that know how to you give it a point and then it kind of goes out and figures out what's out there for defining a business service and things like blueprints. So, we all know, like, anybody who's ever done any DevOps knows that oftentimes these services, either the small services or the big business services, they follow a pattern. So if I can show my system a pattern, like a blueprint of what a service looks like, and then I point it and tell them, hey, here's a starting line for a service, and it can go out and learn that service on its own and define a business service, and then I just recreate that. What we've seen is that companies who've told us that it used to take them 3 weeks to define, a big business service, can now do it in a matter of hours. And when you can do that, that's where it feeds into exactly what you said, Josh, which is, getting all of that information in context and understanding what's linked to what and what impacts what. And the fact that this database is running out of memory is actually, impacting a completely different service in a different place.
Yep.
All right, Nora, one of our attendees wants to know essentially how do we get to what those guys just described from where we are. And the context is we have all these incident management systems and monitoring systems, and all these things are generating data and we're collecting metrics. But how do we distinguish what is the proverbial baby versus the bathwater?
It's a great question, and it's one that I've seen a lot of engineering organizations try to grapple with for a long time. Sort of like I mentioned earlier, that the idea for many years was if we just collect all of the data, we'll be able to see where the problem is. But most of the time we really can't. Again, if that was going to work, it would have worked by now, and it's really not working. And I don't think that the answer is to just continue to ingest more data, because while, yes, it's true that's going to improve the models that IT vendors are developing, it's kind of unfair to ask their customers to just continue to pay for more ingest, more query, dealing with all of that data so that the vendors' models can improve. Instead, we should be looking at asking better questions. So before I had mentioned that for a long time, the focus was on, and I think Yaron said the same thing, how is the memory on my database? How is the performance of my APIs? But that's really not getting at the heart of what we actually want to know. Those are proxies for what we actually want to know, which is, are people able to use my service or my application the way that they want to? How long does it take them to sign up? When they want to, they're looking for a stand-up comedy show to watch. How long does it actually take them to get there? And then once they've clicked in, do they stay or do they leave? If they stay or they leave, why is that happening? So rather than, looking at what new tools we can use and what additional data we can ingest, I think we need to shift towards, and I see a lot of engineering organizations do this, we need to shift towards the questions that are actually what we care about, that really do focus on the business. And by working backwards from what is my customer experiencing and how does that deviate from what I want them to experience, we can get more quickly to the actual, potentially the backend service that's causing that difference, if it is in fact a problem. But it's really about asking the right questions. And I think the questions that we've been asking for a long time, they really haven't gotten us anywhere. Yes, maybe they lead us on a wild goose chase that eventually helps us realize, our Kubernetes cluster wasn't restarting, as we anticipated. But a lot of times things like that happen, and it's not actually affecting our customer experience. So being able to differentiate between what sorts of problems, so to speak, are actually impacting customers versus the ones that aren't, and we don't really need to worry about for right now anyway. And then within the ones that are impacting it, how much are they impacting it? By starting there, we'll get to working in a way that's actually going to benefit our customers and then ultimately our business, rather than starting with, where do I see deviations across my entire system and which one of those might potentially be causing some sort of problem?
All right. Stella, follow up on that. Do I need to become a prompt engineer? Or will the machines just tell me what to do going forward and I can just kind of go about my daily business?
Well, that's the same thing. I would make a parallel with, do you need to become a mechanic if you want to drive a car, right? You just drive a car. So no, because we do the heavy lifting for you. You can just start communicating and using natural language with the data, because with that hard work of prompt engineering and asking the right specific IT questions. For instance, if you are running into some sort of a resource bottleneck, we can bring these insights summarized for you, and also we can recommend what actions you need to take to resolve that problem. We call this a functionality BMC Helix GPT, which summarizes data for you. And on top of that, we have this recommendation for you to, hey, now run this script, whether it's Ansible or Bash or Python, and resolve this issue. So no, you don't need to become a prompt engineer to work with the data. We make it really easy for you.
I actually have a slightly different. I think on the whole, I agree with you in that the idea is to make it easier. But I actually do think that developing as a prompt engineer for any role in IT is pretty crucial. And it's just because, as we've seen many times in history, there's just another layer of abstraction. So it used to be you had to learn a low-level programming language. You had to be concerned with garbage collection. And now, like, I work a lot in Python and JavaScript. I never think about that. I don't really even, I wouldn't be able to adequately sort of explain the mechanics of how garbage collection works. We're adding another layer of abstraction. So maybe you don't need to understand what, sort of different callback functions are and how they work. Or you don't have to understand the mechanics of how Kubernetes clusters run, but you can use natural language, as you indicated, to interact with these systems. But in order to interact with them, you have to be able to speak to them in a way that they understand. And I do think that requires you to be able to articulate what you're looking to achieve and what you're seeing or what you want to see in a way that the system is going to understand. I think at some point, if, as we continue to develop these models, if you ask a question and there's a few different ways to interpret that question, ideally, at some point soon, these models would be able to respond and say, when you say X, do you mean this, this, or this, or something else? I wouldn't say that we're there yet. So I do actually think that DevOps engineers, as their work moves from being more strategic, away from the tactical to being more strategic, I do think that being able to interact in an effective way with these sort of chat-ups tools is actually going to mean that that will be the difference in how quickly they can respond and leverage AIOps compared to those who don't.
So one of the things that's really interesting, Nora. I mean, one of the things that we've been struggling with and really asking ourselves is exactly what you said. How do we better understand our users without them having to be real expert at prompt engineering? Because, it's just like using Google. If you know how to do search versus somebody who doesn't know how to do search, you're going to get better results. Right. But at the end of the day, one of the things that we are doing, and I think that this is one of the kind of the huge leaps that we did was like Stella mentioned, was Helix GPT, is that when you do use LLM, you can fine tune LLMs in different ways, right? And because our subject matter is DevOps and AIOps and IT operations management and IT service management, we were able to fine tune our LLM models that, if I were to ask a general LLM a question, yes, there may be 4 different interpretations, and I would want to ask the user which one of those 4 he means. But once you fine tune it and you tell it, no, we're not going to answer questions like, tell me a joke about a cat. We are going to make the subject matter and train the model to be very specific about the subject matter, then it's going to understand what somebody means when they say K8 instead of writing Kubernetes, and it's going to understand the context a lot better. So maybe and we've seen that we're able to cut down the number of interpretations, which makes the whole conversation more natural. Again, it's where we're going. We're trying to make the whole conversation and the whole interaction more natural, quicker, and get you to where you want to get to quicker. So again, if anybody's looking at this from the technological kind of the prompt engineering or the modeling part of it, it's the more and the more you can understand your subject matter, the better it's going to understand what you mean when you ask a question for a specific subject.
Mm-hmm. Josh, let me ask you a question on top of that, just to flow through. But theoretically speaking, I don't think there's going to be one AI assistant to rule them all. So now we're going to have 4 or 5 AI assistants from different platforms. Are these things going to talk to each other? I mean, are we going to have like, my AI bot will talk to your AI bot and set up a meeting and resolve some issue? Or how is that workflow going to play?
Yeah, it depends how collaborative and nice the people creating them are. I think from my perspective, ideally, these things will all work together, right? I mean, we all imagine in a service that's built and distributed today, how many different, for example, like types of platforms, software languages, and other things are used to bring together services. We've intermixed and we, choose the one that works best for you to, write the service and the thing that you know best. Ideally, I would like to see, use the AI tools and capabilities that you know best, but that doesn't preclude me from talking to Nora and the one that she knows best and integrating that. So I don't know that I have a crystal ball and could tell you this is what everyone's going to do. But I think that would service us in the industry at large better if we can use these in sort of a combined, cohesive effort.
All right, Stella, we have 4 or 5 questions that are all on the same theme, which comes down to where's my cheese and where's it going? And so the question is basically, how does the IT department of the future look like? I mean, are there a handful of engineers jobs? Or are there lots of administrators? Is there no longer a need for the first tier service of folks? I think everybody's kind of curious about, where are they as a human going to fit into this equation?
Great question. Before I go answering how the IT department of the future will look like, I'd like to address a couple of questions which are in the chat Q&A, and that's about automation. It's one thing when you surface all the data, how long do you store it, etc. But we haven't touched much about automated insights from the data. Let's just say there is no, you already solved your noise with noise alert, with alert issues with the causal AI, but now you want to go into prevention mode. You want to make sure that you're running health checks when the system is quiet to make sure there's no further trending towards the incident. So that's where you start automating issues. We have something called intelligent automations, where once you get candidates for whether that's clearing your file system utilization, or whether that's unlocking some bottlenecks if you have long-running database queries, you can easily automate with using AI. And also, we noticed some of the results from our customers were that once they automated insights, more than 60% of outages are prevented. And one of the results is in the first month since they implemented 3 intelligent automations, they had over 1,000 successful remediations. So tying that to where things are going in the future is that you will see much more automation. You'll see much more prevention. You'll see people coming in the morning and see how incidents were kind of self-healed, self-resolved, something that we call self-driving IT or autonomous digital enterprise. More use of automation is for sure there, and in any tool, AI will be part of it. So what will happen is, I think, is just for the purposes of IT, it will be another tool to make you much more productive. So I'm of the positive, optimistic view that AI will not eat all the jobs, but will uncover many different use cases. And then you will become much more creative, faster, and more productive, and IT teams will be able to continue to support and bring value to business services.
All right. Nora, we have an important question. I'm going to kick it your way, but it comes from somebody in the audience. Who's paying for all of this? Where's the budget dollars for all of this coming from?
From data ingest, or what's the...
Data ingest, the platforms, the whole soup to nuts. I think part of the issue that a lot of organizations have is 95% of the budget is already allocated to keeping the lights on. So where do I get the money to pay for all this new stuff? Yeah.
Okay. So I see the question now. So As far as there's mention of the training phase, so my opinion is that we'll sort of converge on a handful of people who develop pre-trained models, and that you'll be able to tune them if you want to, but for the most part, people will leverage models that are actually built and embedded into tools that they already use. So you as an individual company, unless you're actually developing models yourself, probably that piece of it wouldn't be coming from your budget, right? You wouldn't be responsible for that. What I do see happening though is, as a couple of the panelists have mentioned already, it's very expensive to hire somebody who is a Kubernetes expert, and then they just know their primary area of knowledge is Kubernetes, right? And then there's a person that maybe has a ton of experience with SQL databases, right? And that's their primary area. So you have to have a specialist, a highly paid specialist, as you know they should be, but in all of these different areas. And then all of a sudden, to manage one piece of your architecture, you've got like 10 different specialists. What AIOps is doing is it's allowing us to interact and understand how all of these different pieces work, how the SQL databases work, how the Kubernetes clusters work, without having that deep expertise, because we don't have to have all of that data in our brain, and we don't have to be able to comb through, billions of data points to understand how they're performing and how to respond to that. We're actually able to first surface information using tools like we have, internally, and that the folks at BMC have as well, that tells them how performance is, and then moving from just predictive to generative, we're actually able to take action on that. So the marriage of those two being, if you are seeing that there's been a failure on the predictive side, or that there's going to be a failure, the generative side is going to tell you it's going to guide you through the troubleshooting. Or if the predictive side is telling you you're going to have this change in infrastructure demands, the generative side will actually design the optimal sort of infrastructure configurations to meet those demands. All of that means that you can have fewer people doing a lot more. So it'll actually reduce the cost. If it's done properly, it'll actually reduce the cost of all of the people, which are your most expensive resource at the end of the day. Yes, data can become extraordinarily expensive if you have to pay for every single bit of data that's going into your plethora of tools, but really the people are the most expensive resource. And if we can have more people able to do more, and especially by limiting the amount of sort of that like heavy lifting, that tactical work of just diving through data, it'll actually enable them to do the higher value work that we want them to do, which is to make our systems sure more resilient, but actually more effective in providing the tools or the services and experiences that we want to.
All right, Yaron, you have been around this AI block once or twice. So what do you know now that you wish you knew a year ago, 2 years ago, or maybe 5 years ago?
So 5 years ago, I wish I knew more about large language models. Mm-hmm. I mean, they've made such an impact on our industry. And the other thing is that, AIOps is picking up. I mean, it's taking off now more than it ever has. And the types of applications that are done today with reactive, predictive, prescriptive, it's all, we're trying to catch up with a lot of this stuff. We're trying to catch up with the AI technology. And yeah, I'll tell you a story. I was talking to a huge, very large manufacturing company in the Middle East, and I was visiting with them, and they told me that for them, innovation is number one, and they're using all types of IT systems and IT methodologies and new applications, and they're constantly developing new technology for themselves. And one of the things that they told me, that one of their inhibitors to innovation is the fact that a lot of their people, their subject matter experts, have to deal with problem resolution and sitting in war rooms and trying to make sure that what they have is working. And they said, if we could take these experts and have them working with our developers on new innovation and new things that they can do and how IT can go into the manufacturing and innovate and do that better, they said that they could be a year from now if they didn't have to spend all this time taking their most valuable people dealing with, like I think Nora said, sifting through logs and sifting through all sorts of data, trying to find out, trying to gain insight from data. And personally, if you would have talked to me 5 years ago, I didn't think we would get to where we are today, and I didn't think that it would be this transformative to everything that we do, that AI would truly be transformative, even again to old school manufacturing, the large manufacturers. And so yeah, that's what I would have loved to know 3 or 5 years ago.
All right, Josh, we got about 3 minutes or so. What's your best advice to folks about how to get started? I think a lot of folks look at this whole space and they get a little intimidated. So where does my journey begin?
Yep. I would never give somebody advice in this industry to, ignore the tech and don't focus on learning the underpinnings. How do large language models work? I think any knowledge you can gain in this area is going to benefit you. If you have the ability to do, whether it's online courses or, as we all know, YouTube is a great teacher, just go out and dig in and start learning how it works. I think the future of this space, though, is connecting the dots between technical services, which AI is going to deliver to me what the problem is, but connecting that dot to the business. And so I would, even if I'm working in IT, I'm working in operations, I would start to understand what are the business problems. Like if I'm targeting a job at a company, what do they offer? What do they give people? Why do people pay them money? So that I can bring insight to bear in that organization, because I think that we need everybody to say, let's have AI, let's have technology, monitor the systems, tell me when there's a problem, something's gone wrong, so that I can build for the service that we exist to provide and that I can offer there. So I would straddle my time and focusing on learning the IT piece, learning the technologies, what do they mean, how do they work, but don't forget to correlate that to why do people pay for this and why is it valuable?
All right, folks. I just want to know the 3 things that are likely to get me fired and what I should do about them. And I want to ask that every morning and have an answer by lunch. And I think it would be a good day from there, but we'll see how it goes from there. Folks, I want to thank you all for sharing your knowledge and insights, and I'm going to kick it back to Cody to take us out.
Thank you, Mike.
Thank you.
Thanks.
Awesome. Thank you, Mike, and to Josh, Sharon, Nora, and Stella. Thank you all so much for joining us here on Techstrong Learning. It's been such an action-packed hour, so I really appreciate your time. So before I release everyone, just a couple of final notes. Today's session was recorded, and you will be receiving the recording via email here shortly. We'll send it to you as soon as it becomes available. But you can also find it living on the DevOps website at devops.com/webinars. I'll be contacting 2 of our most engaged attendees to win a $50 Amazon gift card. So thank you so much for your chats and your questions throughout our discussion today. If you'd still like to become eligible, there is that post-webinar survey, both pinned to the top of the chat as well as in the handout section. So we would love to hear your feedback there. Additionally, we would like to thank you for joining us for the entirety of our presentation today. We appreciate your time, and we hope to see you at a future Techstrong Learning experience. Have a great rest of your day, and you may now disconnect. Thanks again to our wonderful panelists.
Thank you.
Thank you.
Thanks so much.
Bye.